magnetic stuff. Okay, so guys, the magnetizing power of high speed steel is much more.
Hi guys, you're watching channel Mr. Electron. Today I'm going to try and make some powerful permanent magnets using microwave transformers. Okay, so let's start with that.
So guys, this what you see is a microwave transformer. You see this side the high current winding and this side the high voltage low current winding. Now guys, in one of my previous videos I made this electromagnet using the microwave transformer. So guys, if you haven't watched the video yet, you can watch it by finding the link provided in the description. Now guys, this is a 220 volts to 12 volts DC converter, AC to DC, and this is the electromagnet. You can see one of the converter terminals has been connected. Okay, so let's touch it. As you can see, the spark indicates high inductance. Now guys, let's test it with this metal pulley. Okay, so turning it on. Oh, see, very strong. So the electromagnet is pretty strong, as can be seen here. Now guys, let's measure the current that this power supply is feeding the electromagnet. Okay, point it towards 10 amperes current mode. Okay, keep watching the display screen. Current is only 4.6 amperes. So if we take it as 5 amperes, then 12 5s are 60. So it is going to be 60 watts that this electromagnet is consuming from this power supply, which is not much. Okay, so guys, now what I'm going to need is the material that I'm going to convert to permanent magnet with the help of my microwave transformer. So I was thinking about this lock. You see, this is U shape. So it's going to be the perfect horseshoe magnet, provided it is made of high speed steel. Listen carefully, it should be high speed steel. So guys, as you can see that at present it is not magnetic. Okay, not sticking anything. And this is a magnet piece. It is sticking it. So yeah, let's convert it into magnet and then see what happens if it is able to stick these or not. So guys, now what I'm going to do is heat this piece up at high temperatures with this butane can. Okay, so let's do that. So guys, I hope that it should be closely near about hot enough. Now I will have to turn this off and quickly turn on the supply. A little more. Okay. That's enough. Yeah, the supply has been turned on. I will leave it for some time. You see there is a little bit smoke coming out. Let's see if it works or not. I don't know if you can see the smoke. Yeah, it has vanished now. Okay, so guys, it must be still hot. So let's remove it with this and hope that it works. Okay, so guys, let's pour some of these here. Although there are a few aluminum bits as well, so they won't get picked up. And you see now that it is working and it is picking up magnetic stuff. Okay, the method is working, although the only problem is that it is not very strong. Now guys, let's try the same thing with high-speed steel, which is present in the drill bits, of course, and hope that it gives some better performance. Okay, so let's turn on the butane cylinder. Yeah, I have to be careful not to damage the windings. Okay, now let's turn it off. Then quickly turn on the power supply. Power supply has been turned on. Let's hope that this gets perfectly magnetized. Okay, let's turn off the electromagnet. Okay, the electromagnet has been turned off. Pouring some of these a little more. Yeah, and trying it with this. Oh yeah, actually it is sticking more to the part which was in contact with the transformer. You see, not on the tip but on this side. Wow. The drill bit has been magnetized. That's pretty amazing, guys. You see, the performance seems to be pretty good, much better than the lock. So guys, for this magnetizing project, the drill bits work much better because of the high speed steel. Cool. You see, it is really difficult to get them off. Some of them are still stuck. And guys, you see that it is not picking up this clip. Yeah, but when I try with high-speed steel bit, its magnetic strength is much stronger. Although only one side of it is magnetized. I believe this is the one. Yeah, you see. Okay, so this side is magnetized. Yeah, so I have to turn it because I'm holding it from the other side. Yeah, now it seems fine. Now let's pick it up. Whoa. So guys, the magnetizing power of high-speed steel is much more than any other object present around us.
Guys, don't forget to subscribe my channel and hit that bell icon for similar video notifications. Also, do comment on what else you would like me to add to this present video. Best regards, Electron.
Hi guys, what you see is the armature of a DC motor. Yeah, this motor contains almost identical armature to this one. I will run this motor just for a few seconds. So yeah, and guys, the plan is to remove the remaining windings in such a way that all of them are gone except for just 2 coils. Okay, so guys, now as you can see, all the coils have been removed except for these 2. and these two are joined here at this point on the commutator, and the final end point are this one and this one. So this will be the secondary high current low voltage side. Now comes the part of the high voltage low current side, primary input. Here as you see that this slot, this slot, this slot, slot and this slot, around 5 slots have been used for one coil. Okay, so I'm going to use same 5 slots for the high voltage primary winding, and I'm going to use this much thick copper wire. Okay, so let's start. Okay, and now I can start it from here. Yeah, I'm going to start it from here. So yeah guys, as you can see, this is how we have to do the winding, and it's a long process, so I'm going to quickly do it and show you the completed process. Okay, so guys, here as you can see that the primary winding portion has completed, and I've given it 120 turns for this coil, and these you already know, somewhere around 7 turns. Okay, so let's glue the winding properly. So this is one terminal and this is the second terminal for the high voltage primary side. Now comes the second, this is the secondary terminal for the low voltage high current side. So guys, this was all about the electrical circuit. Now comes the part of closing the magnetic circuit, shorting the magnets, electromagnet formation of this armature. So for that I'm going to use this clip. Instead I will do it like this. Okay, so guys, here as you can see that the magnetic circuit is completely closed now. A little part over here and here is left, but all the magnetic field will be focused on this strip. The transformer is complete now. Let's do the winding resistance check. So for that I'm going to point the meter towards 200 ohms. Okay. First doing check for the high voltage winding side, the thin wires, high voltage, low current. So guys, here as you can see the winding resistance is around 13 ohms for the high voltage low current side, primary 220 volts input side. Now comes the secondary low voltage high current side, and its resistance is only 2.1 ohms, 2 ohms. So yeah, the winding is perfectly alright. Okay, so guys, now comes the time where I'm going to measure the output voltage from this homemade transformer, pointing it towards 200 volts AC mode and connecting the terminals positive and negative to the low voltage high current side. Okay, so guys, the secondary winding has been successfully connected. Now comes the part where I'm going to power up the primary high voltage low current side. So guys, this is the 220 volts supply from the input home socket, and I'm going to connect it. At present it is turned off. So yeah, both the wires have been connected. Now when I will turn it on, you should see some voltage reflected on the display screen. Let's connect it to the main supply. Okay, so guys, here as you can see that the voltage is being reflected as 14.1 volts AC. The transformer is stepping down the voltage, of course, and now let's connect some load to it. Now guys, the secondary winding of this transformer is thick enough, as you can see, so it can easily glow the 12 volts car headlamp bulb and indicator bulb as well. Okay, so let's first connect this indicator bulb. So let's turn on the supply. Okay, so guys, as you can see that it is working and it is glowing this bulb bright enough. Let's test this bulb now. So I've turned off the supply. Okay, so the bulb has been connected. Let's turn on the supply. Okay. So guys, you can see that it is powering up this bulb also, because the secondary winding is thick enough and it can carry current up to at least 10 amperes. Although this transformer is not going to produce that much since it's a modified one and this magnetic circuit is also not completely closed. Let's turn it off. Now guys, this is just a demonstration circuit. You cannot continuously use this as a transformer because the windings heat up a lot, the primary winding, because the number of turns are not that much. So let's remove the bulb and connect a bridge rectifier to convert the generated AC to DC. Okay, so guys, now I'm going to connect this rectifier to the output low voltage high current side, this modified armature to transformer. Okay, so guys, the terminals of the multimeter have been connected to the output terminals of the rectifier, positive and negative. Now I'm going to point the multimeter towards 20 volts DC mode. Now let's turn on the supply. Yeah, I think the terminals are opposite, because of which it is showing the negative sign. Let's reconnect it. So yeah, now it is fine, showing 0. So guys, let's turn on the supply. As you can see, after the rectification, the supply voltage has reduced because of the voltage drop across the rectifier. And guys, in the beginning of the video I told you that this armature of the DC motor was from a motor similar to this one. So now I'm going to run this motor with its armature. How cool is that? Okay, I think actually the supply is turned off and this wire also came out. So let's connect it back. And let's turn on the supply now. So guys, the supply is turned on. It's a little bit risky because everything is connected to each other here. I have to be very cautious, and now I'm going to touch this terminal and it is going to spark a lot. You see, it is working. Cool, right? Yeah, it is working really nice. And guys, this is the 24 volts 5 amperes, meaning 120 watts motor, Japanese geared, that I used in one of my e-bike projects. You can see the power rating here, 24 volts and 5 amperes. Torque of 43 kg centimeter. So I'm going to try and run this motor with this power supply. Okay, so let's connect it. Oops, the supply is turned off. So yeah, I've turned it on now. Let's touch it to the terminal. Yeah, I cannot use it for long because it is heating up a lot. I've turned off the supply.
Hi, you are watching channel Mr. Electron, and in this video I'm going to test if we can run a 220 volts drill machine with a 12 volts battery. So this is a 12 volts battery from a UPS. Let's try and test it.
So guys, the hidden question for today is, who was the first person to invent a battery? Again, who was the first person to invent a battery? So guys, here what I did in this video was I took the drill machine and removed the stator winding. After that, I used two concave magnets of the fitting size and I placed it instead of the stator winding to create a permanent magnet DC motor instead of a universal motor. Now let's test if this drill machine runs with this 12 volts battery, and as you can see that it is not running. Close up, you can see that the motor armature is vibrating a little bit, but still it is not running. Now let's check the resistance of the armature. This will tell us the current flow through the armature. So guys, as you can see that the resistance is very high, 23 ohms, 23.5. Now let's measure the current flow through the armature when connected to the 12 volts battery, and it is only 5.1 milliamps. So obviously the current flow is very low, which can be increased by increasing the size of the battery voltage. Okay, so I have increased the voltage to 24 volts, which is in turn going to increase the current, and you can see that the drill machine has started running. If we are going to further increase the battery, the speed will increase. So now I'm going to feed it 36 volts DC from the batteries, and the speed is much better. Okay, I'm going to connect a multimeter, and I'm also going to connect it to the battery, which is going to tell me the drop. You can see it as a 36 volts, but the voltage is dropping to 22 volts. Let's add another battery, making it 48 volts battery pack, and then test it. So the voltage is at present 30 volts, even though it is 48 volts, but the machine is running pretty good. So obviously, even though placing of the magnets makes it a permanent magnet DC motor, but still the resistance value is very high, because of which it cannot run at 12 volts with a battery. Anyone who says or shows in a video that the machine can run with a 12 volts battery is showing you the fake video. Okay, connecting the 48 volts pack, connected. It's running, but the batteries are draining. You can see that the speed has slowed down. Now I have connected a 59 volts DC e-bike charger. So guys, placing this 2.7 amps 59 volts DC charger for e-bike fed the proper current and voltage to the drill machine